Hello everyone, welcome to this YouTube channel. Today we are going to see a question from the September season of JEE Main 2020. So it's a very interesting question. I'll give you the straightforward method to solve this problem. After that, I'll also give you a shortcut. So we have mod x less than 1, mod y less than 1 and x not equal to y. Then sum to infinite terms of the following series. So x plus y, we have x squared plus xy plus y squared, x cubed plus x squared, y plus xy squared plus y cubed, and so on. Now when you see this question, you have to immediately look at the options as well. The options talk about terms which have 1 minus x, 1 minus y, blah 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 in the denominator. And then some terms have 1 plus x, 1 plus y in the denominator. Okay, and you also notice that there is a condition that x not equal to y given in the question. So it can have some meaning. It can have some meaning. Maybe it can also give you a clue. So how do you simplify this? When you see this expression, so if you call this s, you immediately notice that when you multiply this expression with x minus y, this is going to be x squared minus y squared, and this is going to be x cubed minus y cubed. So you have a hint there. And how do you get that hint? It is given that x is not equal to y. So somehow you have a gut feeling that x minus y is going to come in the denominator, or maybe x minus y is going to appear somewhere, right? So it's given that x minus y is not equal to 0. Somewhere x minus y has some kind of role. So that's what I'm thinking of. So I'm planning to multiply this entire expression with x minus y. Let's see what happens. So when I do that, your first term, let's see, the t1 is going to be x plus y into x minus y, and that will be x squared minus y squared. And let's see what happens to t2. T2 will be it's x squared plus xy plus y squared into x minus y will be, so this is a popular expansion, a cube plus b cube is a cube minus b cube is a minus b into a square plus ab plus b square. So this is this is x cube minus y cube, right? Now let's look at the third term. The third term is, we have x cube plus x square y. We have x cube plus x square y plus x y square plus y cube gets multiplied with x minus y. Now let's see what happens to this expression. So this becomes, and by the way, we can take x square outside as a common term. We can take y square outside as a common term. So this becomes x square into x plus y square into x plus y, and this entire expression is multiplied with x minus y. You can see that x plus y is a common term. X plus y and x minus y together forms x squared minus y squared, and then it is multiplied with the x square plus y square term here. So this becomes x power 4 minus y power 4. Now, what really happened? When I multiplied my s with x minus y, the terms have a pattern now. The first term was x squared minus y squared. The second term was x cubed minus y cubed. The next term is x raised to 4 minus y raised to 4, and so on, right? So now you can combine, you can observe that there are two GPs here. You can just combine the required terms. We have x squared, x cubed, x power 4, and blah blah blah. This can be combined, minus we have y squared plus y cubed, y power 4, and so on. So this is an infinite GP, this is an infinite GP, and it is particularly given that mod x is less than 1, mod y is less than 1. It's given in the question, so that it is, this sum will converge, this sum will converge. We can write the sum to infinite terms of this GP. So this is going to be x squared divided by 1 minus x, and this is going to be y squared divided by 1 minus y. So let's simplify this expression. So our s into x minus y is going to be x square into 1 minus y minus y square into 1 minus x whole divided by 1 minus x into 1 minus y. Of course, when you see the options, there is no xy term in the options. But of course, when you are trying to isolate s here, there is an x minus y which is going to come on the denominator. So it is obvious that the x minus term needs to get cancelled off. So you have to factorize the numerator. Okay. So the numerator is, we have x squared minus y squared, and then we have minus of x squared y plus it's minus of x squared y minus xy squared, and your x minus y term is here. So x minus y is here, 1 minus x is here, 1 minus y is here. Of course, you can cancel off x minus y here, and you can also take x minus y outside. So if you take xy out, this is going to be x minus y, xy into x minus y. This is x minus y into x plus y. So these two are going to get cancelled. X minus y term will get cancelled with the x minus y term on the denominator. So this will be x plus y minus xy divided by 1 minus x into 1 minus y. So that is the final answer. X plus y minus xy divided by 1 minus x into 1 minus y. So let's see the answer. Yes, x plus y minus xy divided by 1 minus x into 1 minus y. Right. So what was the basic idea? You observe that there is some hint. You cannot strictly call this a hint, but you have to have good observation. So there is some condition given here, x is not equal to y. So it immediately strikes that when you multiply this entire expression with x minus y, there is going to be a pattern. Otherwise, the pattern is not very apparent here. But if you multiply with the x minus y term, it becomes very clear. And you have to look at the options. Okay, then it's very clear to proceed from one step to the other step and arrive at the final answer. Now, I'm going to give you a shortcut. Suppose if this method doesn't strike you, we can also arrive at the answer by doing some sneaky way. Okay, I'm going to consider some special cases and so on. Okay. Let's see how this can be done. So what I'm going to do is, the condition, the restriction on x here is x has to lie between minus 1 and 1. And the condition on y is y has to lie between minus 1 and 1. So in this case, what I'm going to do is, I'm going to put y is equal to 0. I'm going to substitute y is equal to 0. So what happens when you put y is equal to 0, every term containing y goes away. You just have x, x squared, x cubed, and so on. So this is going to be an infinite GP containing x only, x terms only. And the sequence is a very common GP of x, x squared, x cubed, x power 4, and so on. And so your sequence will be x divided by, the first term starts with x, common ratio is x. This is infinite number of terms. So it is going to be x divided by 1 minus x. X divided by 1 minus x is going to be the answer. So when you look at the options, you need to have 1 minus x in the denominator. So this is eliminated and this is also eliminated. Now you have to decide between this option and this option. And now that's a tough job because you have already put your y is equal to 0. Now putting x is equal to 0 is not going to give you any additional information. Okay, so you're just stuck here, right? Initially I put y is equal to 0, and of course there are two options which are matching. You see that when you put y is equal to 0, this is going to be x divided by 1 minus x. This is going to be x divided by 1 minus x. And the other two options will not match. So there are two options which are matching. Okay, our answer. And now how do I eliminate between these two? To eliminate between these two, the first thing that comes to your mind is to put x is equal to 0. Instead of putting y is equal to 0, put x is equal to 0. In that case, the answer is going to be y divided by 1 minus y, which again matches with these two. Okay, so that doesn't give any other extra information. It's just a redundant information. It doesn't give you an extra information. Now you're stuck. Okay, now here is the important thing. There is a condition. Now, of course, you cannot think of other simple numbers because, if you plan to put one of the numbers as 0, of course, that this expression is going to be very simple. And that is going to eliminate two of the options, but still you are stuck with two options. And you can't keep both of them 0. If you keep at least one of them as 0, exactly one of them as 0, you are getting two options which is matching with your answer. So, this further substitution is not possible. Further substitutions are not possible. Now, I look at this condition. X is not given to be equal to y. Now, you think about it. Why does it even matter? Why are they giving such a stupid condition that x is not equal to y? Why can't x be equal to y? And it's not going to do any damage to this expression. Will it? It will not. And even in the options, there is no single expression that has x minus y in the denominator. So there is absolutely no reason to worry about x being equal to y. Clear? Even though it is given in the question, and we use this idea as a hint in the first part of our question. Here we are going to use the idea that this information is not required. This doesn't make sense. This is not at all required because if you put x is equal to y, still this expression will make sense. And when you look at the options, none of the options are going to be in trouble because of an x minus y term in the denominator, right? So what I'm going to do is I'm going to put x is equal to y. If I put x is equal to y, what happens to this expression? This becomes 2x, this becomes 3x squared, this becomes 4x cubed. Aha, you're happy now because there is a pattern. This is 2x, this is 3x squared, this is 4x cubed. Now, let's see. Now, s becomes 2x plus 3x squared plus 4x cubed, and then you have infinite number of terms. And this is an AGP. You know that an expression of the form, a sequence of the form a plus d into r, a plus d into r square, and so on, forms an AGP. And sum to infinite terms of an AGP is going to be 1a by 1 minus r plus dr divided by 1 minus r the whole square. Of course, to use this form and to use this formula, you have to add a 1. Okay, I'm just adding a 1. I'll tell you why. Just add a 1 here. In this case, this becomes a sequence which is in the proper form, in the standard form. Okay, in this case, I can use a as 1, d as 1, r as x, and your sum is going to be, let's see this, 1 by 1 minus x plus dr is going to be x divided by 1 minus x the whole square. 1 minus x the whole square. Let's simplify this expression. So this is going to be, so what I have done, I have I compared it with the standard sequence. To make it in the standard form, I just need to add 1. Then this is a AGP with infinite number of terms, for which we know the ready-made formula is available for infinite number of terms. Of course, there is a condition that mod x less than 1 is there. Mod r less than 1 is there. Okay, that is there. Of course. Now I have used this expression where a is 1, your r is nothing but x, and d is nothing but 1. Okay, so it becomes 1 divided by 1 minus x, then it becomes x by 1 minus x the whole square. So this becomes, when you simplify, you have to multiply with 1 minus x in the numerator. So this becomes 1 by 1 minus x the whole square. That is s plus 1. So your s is going to be 1 by 1 minus x the whole squared minus 1. Right? So simplify this expression. So this becomes, we have 1 minus x the whole square divided by 1 minus x the whole square. So we need to have 1 gets cancelled, 2x minus x squared. 2x minus x squared divided by 1 minus x the whole square. Now there is only one option, matching, because only option A will match. Only option A will match with that condition, 2x minus x squared. So this becomes, when x is equal to y, this entire thing is going to become 2x minus x squared divided by 1 minus x the whole square. So this is our right answer. So that is another way to look at it. Of course, you can do whatever is easy, but remember, in an exam, you can't always search for shortcuts. Whatever comes to your mind directly, or whatever comes to your mind in the first thought, the first instinct that comes to your mind, that needs to be applied during the exam. You can't search for the shortcut, and because you don't have that kind of a time. All right, I hope you understood this. If you have any comments, do let me know in the comment box. I may not find time to reply to all comments, but I do read all your comments. Please do let me know your comments. Okay, see you in the next video.